Every single second, 20,000 Coca Cola drinks are opened around the world. 20,000 every second. A simple twist of a cap. A burst of carbonation, a sound recognized across continents, in every language, in every culture. That distinctive crack and hiss is one of the most familiar sounds on Earth, heard in over 200 countries, from remote mountain villages to the busiest urban centers, from Arctic research stations to tropical islands. It's a sound that transcends borders, a universal moment of refreshment. Global scale. That equals nearly 1.9 billion bottles and cans every single day, not per week, not per month, every single day. But how do you manufacture 1.9 billion beverages without changing the taste by even a fraction? How do you ensure that a Coca Cola in Mumbai tastes identical to one in Mexico City, in Sao Paulo, in Sydney? The answer is precision engineering at a scale most people can't comprehend. Engineering tension. If mineral levels in the water shift by 0.01%, flavor changes. If carbon dioxide pressure drifts by a single PSI, the fizz weakens. If temperature rises by a single degree Fahrenheit, carbonation stability suffers. At this scale, microscopic deviations become global problems. A tiny error in Atlanta gets multiplied 1.9 billion times worldwide. This isn't just beverage manufacturing, it's molecular consistency across continents. Signature moment, inside the system. Today, we step inside the billion-bottle machine, the most sophisticated beverage production network ever built. Water engineering. Coca Cola is nearly 90% water. Everything begins here. But this isn't tap water. This isn't even filtered water. This is water engineered to pharmaceutical-grade specifications. Before it ever meets syrup, it undergoes rigorous multi-stage purification. Stage 1. Pre-filtration. Raw municipal water passes through sand and sediment filters, removing large particles, debris, and suspended solids. Stage 2. Activated carbon. Activated carbon filters remove chlorine, organic compounds, and any taste or odor impurities that could interfere with flavor. Stage 3. Reverse osmosis. High-pressure membranes filter out dissolved salts, minerals, and microscopic contaminants down to 0.0001 microns, smaller than bacteria, smaller than viruses. Stage 4. Mineral balancing. Nanofiltration technology reintroduces precise mineral ratios. Calcium, magnesium, sodium, each measured to exact parts per million. Sensors continuously monitor pH levels, target 7.0, conductivity, and total dissolved solids in real time. Why this obsession with water? Because a Coca Cola bottled in New York must taste identical to one produced in Tokyo, Lagos, or Buenos Aires. The water might start differently, but it ends the same. Concentrate and mixing. The secret concentrate arrives sealed in stainless steel containers, heavily guarded and temperature controlled. This is the formula, the legendary recipe locked in an Atlanta vault known to only a handful of people on Earth. Inside massive stainless steel mixing tanks, purified water blends with concentrate in exact digital ratios controlled by programmable logic controllers, PLCs. Mass flow meters regulate every ingredient to within 0.01% accuracy. These aren't pumps, they're precision dosing systems. Sugar or high fructose corn syrup, depending on the market, is dissolved and integrated. Phosphoric acid provides that signature tang. Natural flavors, derived from citrus oils, spices, and botanicals, are added in quantities measured in grams per 1,000 liters. No variation, no improvisation, no eyeballing it, only calibration at planetary scale. The same formula repeated perfectly, billions of times per day. Carbonation science. Now comes the magic. Carbonation. Carbon dioxide is injected under carefully controlled pressure, typically between 3.7 and 4.0 volumes of CO2. But here's the critical detail. Liquid temperature remains between 41 and 43 degrees Fahrenheit. Why? Physics. Cold liquid absorbs carbon dioxide more efficiently than warm liquid. The colder the beverage, the more CO2 it can hold in suspension. This is Henry's law in action. Gas solubility increases as temperature decreases. Too much pressure leads to instability. The beverage will foam violently when opened, creating waste and an inconsistent consumer experience. You've seen this happen with warm soda. The physics is unforgiving. Too little pressure leads to flatness, a Coca Cola that tastes dull, lifeless, fundamentally wrong. The signature bite, the refreshing tingle, gone. Inline sensors measure dissolved CO2 in real time, adjusting injection rates dynamically to maintain perfect carbonation regardless of temperature fluctuations, atmospheric pressure changes, or altitude variations. The same Coca Cola carbonation in Denver, high altitude, lower atmospheric pressure, as in Miami, sea level, higher atmospheric pressure, requires different injection parameters. Physics defines refreshment. Engineering ensures it. Everywhere, every time. Filling and sealing. Empty bottles arrive on high-speed conveyors moving at 1,200 bottles per minute, 20 bottles every single second. First, they're inverted and rinsed with purified water or sterile air to remove any dust or contaminants from manufacturing and transport. Next, they enter the filler carousel, a rotating platform with dozens of filling heads. Here's the critical step: oxygen removal. Before the beverage enters, a vacuum system or nitrogen purge removes oxygen from the bottle. Why? Oxygen degrades flavor and reduces shelf life. Then beverage flows in, precisely measured to within milliliters. Fill level must be exact. Too much and caps won't seal. Too little and consumers notice. Caps descend through compressed air channels at high speed. Torque systems measure every seal, typically 12 to 15 inch-pounds of pressure. Too tight, and the cap cracks. Too loose, and carbonation escapes. That iconic hiss when you open a Coca Cola, it's engineered here. Inspection and quality control. Every bottle is inspected, not sampled. Every single one. High-speed cameras, capturing 500 frames per second, scan each bottle for. Fill level accuracy must be within 2 millimeters tolerance. Label alignment, crooked labels get rejected. Cap placement must be centered and sealed. Foreign object detection, any particle triggers automatic rejection. Laser measurement systems verify liquid volume with precision down to 0.5 milliliters. X-ray inspection systems detect glass fragments, metal contaminants, or density anomalies invisible to the human eye. Any deviation, no matter how small, triggers automatic rejection. The bottle is ejected from the line, logged, and analyzed. At 1,200 bottles per minute, quality control never pauses. Computers don't blink. Sensors don't get tired. This is industrial-scale perfection. Packaging and robotics. Approved bottles move to packaging lines. They're grouped, typically in packs of 6, 12, or 24, and shrink-wrapped using heat tunnels that apply precise temperature for exact film thickness. Robotic arms with suction grips lift and stack pallets with mathematical balance. Weight distribution is calculated in real time to prevent toppling during transport. These aren't simple robots. They're AI-powered systems that adapt to bottle size, weight, and stacking configuration automatically. Warehouse management systems optimize storage locations based on delivery schedules, geographic proximity, and product turnover rates. RFID tags track every pallet from factory floor to delivery truck. Real-time logistics networks coordinate thousands of distribution routes across continents, from purified water engineered to pharmaceutical standards to global distribution networks spanning 7 continents. Coca Cola remains cold, crisp, and consistent across every border. A bottle opened in New York tastes identical to one opened in Tokyo, in Lagos, in Sydney, in Sao Paulo, in Mumbai, in London. 1.9 billion times per day. Every single day. Industrial choreography at unprecedented scale. Global engineering synchronized across time zones. Molecular precision maintained across hemispheres. And it all begins with water. Engineered to perfection, measured to the molecule, calibrated to taste identical, regardless of where on Earth that water originated. This is the billion bottle machine. This is Coca Cola. Subscribe for more deep dives into the industrial engineering, supply chain mastery, and quality control systems that power the products you use every day. Thanks for watching.